What if you looked up tonight and saw rings stretching across the entire sky? Not the moon, not clouds. Rings made of rock and ice, a permanent arch from horizon to horizon, every night, forever. Tonight, we're going to find out exactly what that would mean for Earth, for our climate, our seasons, our oceans, our night sky, and whether a ringed Earth could ever support life as we know it. Earth's rings would be made of the same material as Saturn's: rock, dust, and ice, ranging in size from microscopic particles to chunks as large as buildings. They'd form in the equatorial plane, held in orbit by Earth's gravity, and they'd be extraordinarily flat, potentially thousands of kilometers wide, but only a few hundred meters thick. From space, they'd look like a solid disk. Up close, they'd be mostly empty space, individual particles separated by kilometers, orbiting in a precise gravitational ballet. The rings would cast a shadow on Earth's surface below, a dark band across the tropics, where sunlight is permanently partially blocked. From the equator, the rings would appear as a thin, brilliant line cutting straight across the sky. From mid-latitudes, they'd arc dramatically from horizon to horizon. From the poles, they'd appear as a ring on the horizon, glowing at sunset and sunrise, fading in between. Every location on Earth would have a completely different relationship with the same rings, an object so large it looks different depending on where you stand. The shadow the rings cast would fundamentally alter Earth's climate. The shadow band over the tropics would reduce solar energy reaching those regions, cooling areas that are currently the warmest on the planet. The poles, already receiving less sunlight due to the angle of Earth's axis, would be further darkened by ring shadow during certain seasons. Ice sheets would grow. The climate zones we rely on for agriculture would shift. The regions that currently feed billions of people, the grain belts of North America, the agricultural heartland of Europe, the rice paddies of Asia, all of them calibrated to current climate patterns, would need to adapt to a world where sunlight is partially rationed by a planetary ring system. And here's where it gets complicated. Earth's 23.5-degree axial tilt means the rings would alternately shade the northern and southern hemispheres as Earth orbits the sun. One hemisphere would receive more ring shadow during its winter, making winters colder. The other during its summer, making summers cooler. The seasonal variation we already experience would be amplified and complicated by the geometry of the rings. The night sky on a ringed Earth would be extraordinary. The rings reflect sunlight, meaning they'd glow even after dark, a permanent brilliant arch spanning the sky brighter than the full moon in many regions. True darkness, the kind needed for astronomical observation, would be rare. The stars would compete with a ring system that never sets, never disappears, never gives the sky fully back to the night. And the rings would shed debris constantly. Particles at the inner edge of the ring system would gradually spiral inward due to atmospheric drag and gravitational interactions, entering Earth's atmosphere as a perpetual meteor shower. Not the annual events we celebrate today, the Perseids, the Leonids, but a nightly display of shooting stars, every night, everywhere on Earth. Beautiful from the ground, dangerous for anything in orbit. Any satellite passing through the ring plane would face continuous particle impacts, making the orbital zones we depend on for GPS, communication, and weather forecasting permanently hazardous. Space travel would not be impossible, but launching through the ring plane would require armor, careful timing, and routes that minimize exposure to ring material. Life on a ringed Earth would be possible, but different. The altered climate zones would push biodiversity toward the mid-latitudes, where ring shadow effects are less extreme. Polar ecosystems would be more extensive, more ice, more cold-adapted species, less summer melt. Tropical ecosystems would be cooler, potentially more stable, less prone to the extreme heat events we see today. Human civilization would have developed under a sky dominated by the rings. They'd be as normal to us as the moon is now. Agriculture would be calibrated to ring shadow seasons rather than purely solar ones. Navigation, before modern technology, would use the rings as a reference, a permanent compass in the sky, always aligned with the equator. Every culture on Earth would have mythology, religion, and cosmology built around the rings. They'd be the defining feature of our world, more prominent than the sun for much of the night, more constant than any star. A civilization that grew up under rings would see the universe completely differently than we do. Here's the remarkable thing. Earth may have had rings before. Scientists believe the moon formed from a ring of debris after a massive impact 4.5 billion years ago, when a Mars-sized object called Theia struck the early Earth. The debris from that collision formed a ring around our planet, and instead of staying as a ring, it coalesced into the moon. We didn't get Saturn's rings. We got something that turned out to be more valuable. The moon stabilizes Earth's axial tilt. Without it, our axis would wobble chaotically over millions of years, producing climate swings so extreme that complex life might never have gained a foothold. The moon drives our tides, which may have been critical to the emergence of life at the boundary between sea and land. The moon we have is not a consolation prize for missing out on rings. It may be the reason we're here to wonder about them. Every planet with significant rings in our solar system, Saturn, Uranus, Neptune, Jupiter, has them for a reason. Rings form when moons get too close, and tidal forces tear them apart, or when impacts shatter existing moons into debris. They're not permanent. Saturn's rings may be only 100 million years old. They formed while dinosaurs walked the Earth. In another 100 million years, they may be gone, pulled into Saturn by gravity. The most beautiful thing in our solar system is temporary, and the thing we got instead, our quiet, gray, tide-pulling moon, has been with us for 4.5 billion years. Stability over spectacle. That trade may have made all the difference. The solar system is full of worlds that made different trades than ours. Rings instead of moons, chaos instead of stability, spectacle instead of life. Next video, we're asking what happens when one of those extreme worlds passes close enough to affect us directly. Subscribe and hit the bell. You don't want to miss what's coming. See you in the next one.